I am VHELARASU. In this video, I will walk you through the design and analysis of a circuit for filtering purposes. We will discuss results from the lab, the design process using ADS 2024, and compare the simulation result with practical measurements. From the lab, we determined the frequency range of our filter. The minimum frequency observed is 862.56 M. The maximum is 874.14 M, and the calculated center frequency is 869.65 M. These results are the basis for the designing circuit. This shows the frequency response of our original circuit. As you can see, the response demonstrates a notch around the center frequency, which aligns our calculated values. Okay. To design the circuit, we used ADS 2024 to create a filter circuit that meets the desired specification. The design involves calculating the capacitance and inductance value using standard formulas derived from the frequency response characteristics. From this design, I choose key components, parallel LC circuit, because it provides an effective way to target the center frequency while maintaining the desired bandwidth. Here is the stimulated frequency response in ADS. As you can see, that the center frequency and bandwidth match closely with our lab result, demonstrating the accuracy of design process. Okay, next, the Smith chart here provides insight into the impedance matching of the circuit. This is critical for ensuring minimal signal loss at the center frequency. And as you can see, this picture shows the Smith chart for previous lab. As you can see, the yellow color in the picture indicates S11, while the blue color indicates S21. Okay, for the next part, I will pass to my groupmate LEONG.
I'm LEONG. Now I will present the calculation theoretically. So for this lab assignment, we will design a maximally flat bandpass filter, and the n is equal to 3. Here's the drawing for our circuit. So to find the value of L1, C1, L2, C2, L3, C3, this is the calculation part. The first one, I calculate the bandwidth using the formula F frequency maximum minus frequency minimum over center frequency. The value I get is 0.013, and then to get this omega, I use the formula 2 pi fc, and I get the value 5.46 giga. And then here's the calculation. The value that I find for bandwidth and omega, I will use it in L1, L2, and L3 and those capacitance. So the value I get for L1 and L3 is 0.70 mH, and L2 is 5.52 picohertz. C1, I get the same value as C3, which is 0.048 picofarad. As for C2 is 563.53 picofarad. That's all from me. So I will pass to my groupmate KELVIN to tell about the circuit.
My name is KELVIN Kennedy. Now I will show the circuit that we designed using software ADS. This is the circuit that we have designed from the circuit. You can see the value of L1, L2, L3, C1, C2, and C3. a bit these values are a bit different from the calculation because we have made some tuning. So this is the tuning that we have made. Here is the graph we get for S11 and S21. For the M1 is maximum frequency, M2 is minimum frequency. For the Smith chart, we get like this so far for S11. As the conclusion, the stimulation result is slightly same with the result in previous lab.